Okay, so from last week, 2 weeks ago, actually mine is a new iPad, so I don't think it works, but yeah, we can try that later, maybe after this one. Okay, so one thing that strikes difference between the macroeconomic model and the microeconomic consumer decision-making model is that the budget constraint looks a bit different. Okay, what's different? So there's look at the budget constraint here. This one looks like the one that you guys probably saw in a microeconomic class, right? So the intercept up here. Actually, I can at least do. Oh no, I cannot do that. Okay, sorry. So the intercept up here, this point stands for the point where you sacrifice all your leisure and you spend all your leisure time to work. Okay. So how many hours or in total do you have in terms of your time? That's H, right? Okay. So if you spend all H hours on working, then how much wage in total you will get? That's H times the wage, right? Wage rate. That's the total wage you get. And plus the dividend you receive from the firm, and minus the tax that the government collected from you. That's in total your consumption if you sacrifice all your leisure time. So your leisure is 0 and your consumption is WH plus pi minus T. And then this slope, if you want to do 1 unit of leisure, then your consumption will go down by how much? That's going to be W, right? So 1 unit here and W unit down here, that means the slope is W or minus W. Okay, so this is one intercept and you have a slope which is W. I mean, from high school math, you should know that 1 point and 1 slope gives you 1 line, right? So you can draw this line all the way down here. But the thing that you need to notice is that what happens when you basically sacrifice you basically spend all your time trying to do the leisure. Or basically, what is the time when your consumption is 0? Okay, when your consumption is 0, this is the line, right? When consumption is 0, you can calculate that leisure is the W is divided here. You move it W to here, then your leisure is H plus pi minus T divided by W, right? And that's the term here. Okay, and here I showed an example where pi minus T is negative. So when pi minus T is negative, pi minus T is negative means T is greater than pi, right? So when pi minus T is negative, H plus this term is less than H. So the intercept is before H. And that is a possible solution, right? Okay, but the other case, actually this intercept point is still there. Last time I drew a line here, right? Remember? It connects all the way down to here. This point, your leisure is still H plus pi minus T divided by W. But here, when T is less than pi, this term is positive. So what it suggests is that when you have your consumption equals 0, your leisure is H plus some positive terms. That means you spend more hours on leisure than you possibly can. It's more than your physical time of hours per day or per week. So that's not possible, right? So because it is not possible, so here we cross out them. We basically strike a line here and say that, okay, your maximum time of leisure is gonna be h. That's by like law of physics. Okay, so that's how many hours you have. So we cut a line here, then it's clear that this is h. Okay, so the cut line at h. And then this point is gonna be what? This point is gonna be, okay, so your leisure is gonna equal to h, right? So go back here. If your leisure is h, then WH and WH cross out. Your consumption is going to be equal to pi minus T. Okay, so that's why this is pi minus T. Okay, so last time we were talking about that we actually need to consider there are two cases, and that's why. Okay, and like I said last time, because this one is less interesting, okay, less discussion came out here, and also it's not really reasonable to assume that if you have no consumption, then you still cannot have any, and you still cannot spend all your time on leisure. That's what it means, right? Or when you spend all your time on leisure, your consumption has to be negative. But what is negative consumption? It's not clearly defined here. That's why we really don't consider this case that much. We mostly consider this case. Okay. 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 Now let's start the next part of this chapter, the representative firm. Okay. So this firm has a production function, and as the microeconomists assume that this firm is gonna do profit maximization. And this profit maximization, like the utility maximization that we've done for the decision maker, the consumer, it will gives you something on the labor market. And for the firm, what you get here is the labor demand. Okay. So this is the production function. By the way, as you probably should notice, I updated one version of the slide. Okay, so this slide is different from the slide if you downloaded last week, 2 weeks ago, sorry. I updated this a few days ago, I forgot which day. Okay, so this is firm's production function. Here, Y is the total production. Z is basically a constant in front of the production function A, F. Okay, F is the really production function, or sometimes we say that Z times F, the whole thing is a production function. Depends on how you define it. But anyway, we have a function F, and Z is a constant in front of that F. And Z, we have in macro, we have a specific term, define it. It's called total factor productivity. Okay. So when I speak of total factor productivity, I'm speaking of this Z. Okay. And inside the F function, we have two input. One is K, that's the capital stock, and the other is ND, that's the labor demand, or how many labor hours do this firm hire, basically. So basically, this firm use capital and labor to produce, and K is the amount of capital this firm has, and ND is the labor that he has. And you throw these two variables into the function F and times a total factor productivity, Z, then you got the total production. The Z here, also sometimes people refer to it as the technology. Okay, technology. So if you have really good technology, then you can So Z goes from 1 to 2. That means your technology somehow can use the same amount of input K and N that produce double amount of output. So that means your technology is better, right? Okay, so about this production function, we usually assume that the f function is constant return to scales. Do I need to define what is constant return to scale? I mean, it's not a shame, okay? So if you don't know what I mean, this f function is constant returns to scale, please raise your hand. Okay, good. Did you guys learn this in micro last semester? Or, okay, good. Okay, so that's CRS, and when the output, when the labor input or the capital input increase, the output is gonna increase. Or in math term, that means the partial derivative of this f function on either k or nd is positive. And the marginal product of labor decreases as labor input increase. That means what? The slope is decreasing. It's in the marginal product is decreasing. Yes, sorry. The slope is so the slope is positive, but as you increase the nd or the kd, actually, the slope will decrease. And also this is if you keep either the capital or the labor constant and you move the other things, then your slope is decreasing. But if you increase the capital, then your marginal product of labor is increasing and vice versa. So the cross derivative is positive, basically. Is that clear? Can someone find me some new battery for this? Any question about this? No? By the way, a trick in my class is that you should try to ask more questions. Because my really bad habit is that if no one's asked question, I don't want to do it, but it's sort of auto. I will start speaking faster and faster. And if I speak faster and faster, that means I will finish what I plan to teach before my planned time. Then I will have few weeks left there. Then I will have to, teach you guys something new, right? Then I have to teach something that I didn't plan to do. Then you guys final or midterm will become more material there for you guys to be tested. So probably in your best interest is you try to ask more questions. Okay? Even if you just have a little bit of things that you feel confused, it's really okay if you ask questions. Okay? If someone else gives you that eyesight saying, you shouldn't ask that many questions, you are annoying, I will definitely punish that person, okay, not you. So please ask more questions if you can. Okay, so this is output increases with increase in either the ND or K. Okay, so if you fix K, here I'm fixing K, but I increase, I'm fixing K. I'm saying that for any given N, you can see the slope there. That's the marginal product of labor, MPN. The slope is positive. Okay. And if you're fixing this ND for any K star, then your MPK, marginal product of capital, is also positive. And the MPN is decreasing as the ND increases. That's basically saying that this MPN, the slope is decreasing. Okay? And so if you draw the MPN, it's going to look like this. If you increase the labor input, and fixing K as well, okay? Fixing K, and you increase your labor input, then your MPN is gonna be decreasing. Okay, but if you increase K, what happened? Then the whole line parallelly move up. Okay? Can you picture that? So because this is MPN, the y-axis is MPN, and the labor input is ND. There's no K here, right? Before, in the previous graph here, this is fixing for 1K. Say K is 100. So what if I increase the K from 100 to 200? This will happen. The whole line will move up. Is that clear? Okay. And what happens if the total factor productivity, the Z, increases? Okay. This one is also clear because Z is a constant in front of this F function, right? So, by the way, you see that the origin is the production function cross the origin. That means we are sort of assuming that F0, 0, that when you have 0 capital and 0 labor, then the F output is 0. Okay, so it's a line like this and cross the origin. And if you increase the Z in front of it from Z1 to Z2, then it sort of shift up, but it's not a parallel shift up because it has to pass the origin as well. So it's a sort of a it's not an axis move. It's a proportional increase, basically. Proportional increase. So say that originally the production is 100. Okay, so F function gives you 100. So and the Z is 1, and Z now increased to 1.1. Then all your production is increased by 10%. No matter what is the current output of what's your current output, the total output is increased by 10%. So it's a proportional increase. And when it is an increase in Z, what happened to MPN? Because that's similar to K, right? So it's also a variable that's out of the picture here. So it also moves the MPNs up. It says going that way, but it's also going up. So it actually didn't matter which direction you point to. It means the increase. Okay. And to do profit maximization, because our model here is so simple, it actually boils down to a very simple equation. That is your MPN must equal W, your wage rate. Because MPN is your marginal product of labor. In plain English, that's if you hire 1 more hours of labor, then how much more you will produce in terms of real term. That's if your production is a car, that's 1 car or half a car, something like that. Okay, and W is also in real term how much you need to pay this person. pay this 1 more hour, sorry, because W is wage rate, right? So how much more you need to pay this person for this extra 1 hour. So basically what I'm saying is that this is your marginal cost. This is your marginal benefit. So that's the general principle in economics, right? You guys, I've asked you guys before, so all of your major back in college was either directly econ related or management schools, business school related. So you should know that the general principle in economics is that you should equate the marginal benefit and marginal cost. That's that. Okay? And in sort of graphic view, this Z times F of K and ND, that's the production function we have, right? This is production function. Okay. And what I'm trying to do in terms of profit maximization is basically trying to find, so, and this line, straight line here, this straight line, is W times ND. That's the total wage you need to spend if you hire ND unit of labor, right? So if you hire, because it's the wage rate is a constant, so the more you hire, then if you hire 1 hour, then you pay W. You hire 10 hours, then you need to pay 10 times W. So that's ND times W, right? And we basically trying to find the difference between, this is the production, this is the total production, this is the total cost. We try to find the difference that's maximized. We're trying to find where the difference maximizes. Okay. And the way to do this, the simple way is you graphically move this line parallelly up and see where it tangent to the production function. That's where the W will equals MPN. So you find that this difference is maximized. Okay, so and you find one single labor number N star that's maximize the labor input. Maximize the profit. The labor input that maximize the profit. Okay. So this is general principle, and this is graphically what it looks like. And what you learn from here is that your profit maximization gives you one number. That's the N star. Remember, we usually assume the capital is something fixed. It cannot be changed. At least in short run, right? In short run, we sort of in economics we define short run being the period of time where capital is fixed, right? Also, here the total factor productivity Z is also fixed. So the only thing you can change is ND, how much labor you hire. Okay, so you will find an optimal amount of labor. That's the N star. So in other words, if I gives you 1 W, then you will tell me how much labor you want to hire, right? So this one tells you if the wage is specifically this wage rate, W, then I will hire N star of labor. If I change this wage rate to a higher wage rate, then the tangent point will probably goes to here. It goes a little bit down. Then there's a new optimal N, right? So generally speaking, what I'm trying to say here is that as you increase the wage, the labor that you want to hire is less. As the market wage decrease, you want to hire more labor. So this is the graph. Basically, you increase the wage, the quantity of labor demanded is decreased. You decrease the age, the quantity of labor demanded is increased. Remember, the wage rate, the firm also take it as given. So what it means is, this is so-called basically the labor demand curve. But because W must equal MPN, this line also happens to be the MPN. See the tricks here? because W equals MPN is the maximization condition, right? So this line is exactly the MPN line. The MPN line we saw here. This is the MPN line. Basically, for some wage rate, I'm going to find the MPN and come down to see what's the labor input that I will hire. So MPN is exactly the labor demand line. Is that clear? Okay. Okay. And okay. In practice, what I mean in practice, in terms of empirical study, economists usually use the so-called Cope-Douglas production function to model this Y, or the production function. Okay, so you probably recall this from micro, that so-called CD production function means something looks like this. So it's K to the power of alpha and ND to the power of 1 minus alpha. Here, alpha is a parameter between 0 and 1. And the economics sort of interpretation of this alpha is so-called the capital share in income. Okay, or basically how much production is attributed to capital. Okay, in terms of percentage. Okay, and the empirical estimation of this in the US is 30%. That means alpha is 0.3. Therefore, if we have Y is real GDP. Okay, and we do have K. K, that's the amount of total capital stock we have. And ND is total employment. Okay, so we have this number, and also alpha have at least an estimation. So we can back out so-called Z, the total factor of productivity. So Z is going to be defined as something like K to the power of 0.3 and ND to the power of 0.7. Yeah, I don't know why there's a, this is a comma. Okay, I got it now. Okay, that's a comma. So, and we define these things as, we define this thing as a solo residual. Residual means something left out, right? So this is, because this is an equation, we have all these other variables. This is what it left out. Right? So this is called what is called residual. Solo is the guy who defined this. Okay, who sort of invented this. And why is this useful? Okay, this is the solo residual from 1950 to 2010. You can see that the solo residuals goes basically generally goes up in a very straight line. Okay, and this line, as we will show later in this course, is one of the best predictor of the, for example, the U.S. stock market or the U.S. Total GDP growth. What it means is that if we try to use one simple model to predict the macroeconomic, like the great picture of production idea, then we should use this model because it captures most of the variation, especially when it goes. So basically, when people ask you what can be used to explain the terms in the up and down in macroeconomics, mostly what it attributes to is the total factor productivity, or in terms, that's what we call technology. So technology or the productivity is what it really pushed the economics growth. That's at least this school of macroeconomics belief. Okay. Okay, that's chapter 4. Any questions from you guys? No? No? Okay, then we'll take a break and we'll come back at 3:30. Okay, and we'll start next chapter. I will upload the slide for chapter 5 during this break.